All right, today we are going to look at the second part of our interest, which is called compound interest now. So it's a different type of interest. It's still something that you're going to get if you have money in a bank account, or something you pay if you take a loan out for, say, a car or a mortgage or a credit card. However, it's now called compound, and it acts a little different. So if we look at our table now, we still have $1,000 like that simple interest account, but now we see the amounts as they are going forward. So it goes 1,000, 1,080, 1,166.40, 1,259.71. So we can see right away that we're not adding the same amount every time because we have these dollars, or the cents, that are being added. And again, if you look up here, it says 8%. So we're still doing 8% as the simple from the previous page. But now it's called compound, and it's compounded annually. And annually means one time per year. So you're going to get that interest one time per year, but now it's going to be compound, and we're going to look at what compound means. So again, since we're not adding the same amount each time, chances are we're multiplying. So remember, to find your multiplier, you take a y value divided by the previous. So I'm just going to do the ones that are no cents. I'm going to do year one, 1,080 divided by 1,000. And when I type that in, I get 1.08. So my conjecture or guess is that I am multiplying by 1.08 now, the whole way down. And we can check that by taking our calculator, doing 1,000 times 1.08. That's the 1,080 times 1.08. There's a $1,066.40 times 1.08. There we go, 1,259. Notice we're talking about money, so that's why we rounded to 0.71. So when we're talking about money, always do two decimal places, times 1.08. So 1,360. And we'll follow the normal rules of rounding. So this is two decimal places what we want, and there's an 8 as the third, so we got to round that up to 49. All right, so we know the pattern is times 1.08. It says by what percent has the balance increased by the end of the fourth year. So remember, that's where we're going to compare year 4 to year 0. So I'm taking 1,360.49 divided by 1,000. And that gives us 1.36, or if we make that a percent, 136%, subtract the 100%, and we get a 36% increase. So that's pretty good. If you recall, on the previous page for the simple interest, over 8%, but simple over the 4 years, there's only a 32% increase. And the reason why the compound is going to be higher is because when we multiply by 1.08, we're getting 8% of what is currently in our account. So the more money that's in our account, the more the 8% is going to be adding to the account. Where on the simple, remember, we only really got 8% of our initial amount, and then we just kept adding that same amount, the 8% of the initial amount. So we're adding the same thing each time. Here, we're getting 8% of what's currently in our account. So as the more money in the account, 8% of more money is going to be more than $80. And you can see that we are adding more than 80 in the end. So compound interest, if you have the same percent, it's going to grow faster because you're getting what I call interest on top of your interest. So then it says rewrite the information from the table as a sequence. So again, we'll do the first couple, 1,000, 1,080, 1,166.4, 1,259.71, ... And again, since we're multiplying now, this is going to be geometric. Our initial value is 1,000. And our generator is what we do to get from one term to the next. So we're multiplying by 1.08. And we're multiplying, we call that the multiplier. Okay, if we go to graph this now, Again, we still have years on the X, money on the Y, and we can start plotting our points. And if you look at that at first glance, again, it doesn't really look exponential. You can see it's kind of curving a little bit, but if we went out a lot more years, we would see a lot more of a curve than a straight line. And again, for right now, we're not going to connect the points just because you get your interest at the end of the year or once a year, so it would really kind of be flat and then jump. So we're not going to draw anything. And for our equation, remember, since it is going to be geometric, then our equation has to be in the y equals a times b to the x form. And y is equal to our initial value of 1,000 times 1.08 to the x power. So when we go and say how much money do we have after 20 years, x is the number of years, so we just have to type in y equals 1,000 times 1.08, plug 20 in for x. So we get $4,660, and again, always around the 2 decimal places, 0.96. So if we compare that to the 20 years on the simple, we're making a good amount more money, almost $2,000 more just by having it in that compound account. All right, so the basics for the compound interest account. All right, so the bottom line, if you want to come back to your notes for compound interest, always come back here. So compound interest is always going to be exponential. So it's always going to be y equals a times b to the x. So we're exponential. And how do we get our a and our b and everything else? So our a is the initial value, or the starting amount. The b is what's a little tricky. For this problem, it was pretty easy, but as we go to other problems, that's where it gets a little tricky. So your b is your percent increase each compound period written as a multiplier. And so again, each compound period means how often you're getting that interest. So we were getting that interest one time per year. So we were adding 8% one time per year. So we did 100% plus 8%, which is 108%. So if I do that over here, we were doing, for the multiplier, 100%. Our percent increase was 8% per year. So we did 100% plus 8%, which is 108%. And then we moved that over 1.08. But again, we're going to see some examples where it's a little bit more tricky. And then your x is equal to the number of compounds. And a compound is how often you're getting that interest. So in our example for this problem, it was you got your interest once a year. So when we did 20 years, we did 20 compounds because we got interest once a year for 20 years. So we're going to come back to this a lot. This is where we always want to come back to if we have a compound interest problem. And so now we go into the little bit trickier ones. All right, so now we have our third account. It's still 8% interest. It's still compound, but now it's compounded quarterly. If you do something quarterly, you do it 4 times a year. So it says a third way to invest your money is an account which offers 8% annual interest compounded quarterly 4 times a year. This means the 8% is divided into 4 equal parts over the year. So you're not getting your 8% 4 times, you're getting 8% broken into 4 equal parts, and each of those parts you're given 4 times per year. So it says, what percent increase do you receive each quarter? So if we're getting 8% over the entire year, and that's broken into 4 equal parts, that's going to give you 2%. So you're going to get a 2% increase each quarter. Things we have to remember are compound interest accounts, arithmetic or geometric. They are geometric. Again, geometric and exponential have the same equation, so you can write geometric / exponential. They're going to be the same equation. Our initial value is still 1,000. Now, if we're getting a 2% increase, though, remember what that's going to mean is we're going to have to take the 100% plus 2% now, which is 102%, or 1.02. So our multiplier should be 1.02. And again, when we wrote this here, it says the percent increase each compound period written as a multiplier. That's what we meant. We were getting 2% each quarter, which was their compound period, written as a multiplier. So we had to add 100% to it and then move the decimal place over. And now also, what does our input value represent? That's changing now. So remember, X is the number of compounds. So how often are we getting our interest? We are getting our interest 4 times a year or each quarter. So X now represents number of quarters. And so as we go along here through this table, we're now going to multiply by 1.02. So we'd have 1,020. Again, the way we're doing this is times 1.02. Times 1.02. $1,040.40. And we're just constantly multiplying by 1.02. $1,082.43. So again, that was after 4 quarters, or 4 quarters is 1 year. So this is our amount after 1 year. 5, we again just keep multiplying by 1.02. This is all money. All right, so that's again just multiplying by 1.02 is how we got that. If I wrote that as a sequence, I would have it as 1,000, 1,020, $1,040.40, $1,061.21. As we go now to graph this, remember our X value changes now. Our X is no longer years, it is now number of quarters. Our Y is still money. So 0, 1,000. 1 is 1,020. $1,040.40. 1,061. 1,082. 1,104. So that's an approximation of where we're at for all of them. This one's off. That one's right. Actually, all of these are off. so there's our graph after plotting those points. All right, so then it says write an equation for the investment where y represents the value of the investment after x quarters. So again, it is exponentials, or sorry, compounds are still exponentials, so it's still going to be y equals ab to the x. So we have y equals our initial value is 1,000, and remember we're multiplying by 1.02, and now x is in the exponent. So now our last question is, by what percent has the balance increased by the end of the 4th year? So this is a kind of a two-part question. First thing we have to do is find the value after the 4th year, because we don't have that yet. We only have 8 quarters, which is 2 years. So in the 4th year, after 4th year, the 4th year would be how many quarters? That's what we have to figure out first. Well, 4 quarters in a year times 4 years is 16 quarters. So that's what we have to find first. And then we would do y equals 1,000 times 1.02 to the 16th power. And that would give us $1,372.78. And so then I have to compare that to the $1,000 we started with to find the percent increase. So I'm taking that year 4 value, dividing it by our starting amount of 1,000. I get 1.372. I'll just do 1.37. Now I have to take that, make it a percent, subtract 100, and I get 37%. So it's a 37% increase. So comparing them all, summarizing this, I have a 37% increase here, where when it was exponential with the simple compounded one time per year, it was only a 36% increase. So this was even better. The compounded quarterly was even better because we're getting the interest more often. Okay, and again, the more money we have in our account, the more percent we're going to have. So we said compounded quarterly was better than compounded yearly. So what that means is compounded monthly would be better than compounded quarterly, because you're getting the interest every month instead of every quarter. Compounded weekly will be better than compounded monthly. So what would be better than compounded weekly? All right. I know this was, I hope you enjoyed this. We'll practice a lot more with this. It takes a lot of practice.